Welcome. This is the presentation video for the CSCI 717 fall term for software construction presented by Cody Gullickson. The purpose of this project was to take and apply core concepts from the course and apply them to a simulated real-world project. Developing a web application was the project type that I had settled on. Specific to this project, it would be an N-tier application architecture consisting of a database layer, API layer, and presentation layer. Motivation behind this project was to understand the start to finish components present within the application development process, from gathering requirements, drawing the architectural concepts, and writing the code for each project component. The original scope for this application was to develop a calendar management type of application that the user could track and record different activities throughout the month. However, between the project planning phase and requirements gathering phase, the scope of this project changed to an application that now allows a user to manipulate data elements similar to tasks and purchases, performing CRUD, create, read, update, and delete operations along the way. Unfortunately, the scope for the project continued to change through the development process, leaving some of the original requirements in an unfinished state. From an architectural perspective, the application breaks down into three main components: a database layer, an API layer, and a presentation layer. The database layer has been developed as a relational database implemented with a Microsoft SQL Server environment. The table schema mainly revolves around a person object, a task object, and a purchase object. However, subtables have also been added to help with the one-to-many relationships between multiple tasks and purchases assigned to a specific person. The underlying framework for the API layer is that of ASP.NET. The technology utilizes the C# programming language and strong object-oriented programming principles. The API is also the intermediary between the SQL database and client application, utilizing the system.data.SQL client libraries for CRUD operations and stored procedure invocations. The API has also been designed in such a way that each major component has its own route controller for HTTP requests. Finally, the presentation layer to this application has been developed as a web application built using the Angular framework. Incorporated into this Angular build is the Angular material library, supplying some of the out-of-the-box components such as table controls, tabs, and material cards. One extremely useful tool that was used when developing the Angular front end was the Java OpenAPI executable. This executable takes an API specification generated by a Swagger NuGet package inside the API itself and automatically generates the JavaScript HTTP request code for creating the connection between the client and the API, saving time and creating consistency among requests. Other miscellaneous tools used by this project include GitHub, acting as a code repository for the complete code base, as well as Lucidchart and Microsoft Visio for creating and generating diagrams and documents during the architectural design process. When navigating to the localhost URL of the application, the first page that is presented is the home page. From here, there exists a login button, as well as a new user button. As mentioned before, create, read, update, and delete options were each considered for each type of data object stored. Choosing to log into the application using an existing username and password, a request is made from the client to the API. With this application, I can log in with an existing username, supply a password, and submit. By supplying this information, the application takes the response from the API and the database and saves it into the local storage of the browser, where other components can use variables within. Additionally, the application can generate new users by going to the Add Users tab. In this tab, the following form values can be entered, submitted to the API, and populated into the database. When a request for a new user is successful, a person row is added to the database and a new bank row is instantiated using the person ID that was recently created. Looking more at the left navigation bar, there are several key options to choose from. The user could manage groups, which could consist of reading from a list of all the groups, assigning a user to a group, creating a new group, updating values to an existing group, and in the future, deleting those groups. The user could also manage tasks, manage purchases, and view the bank value for whoever is currently logged in. Further demonstration for this application is related to the task feature. By navigating to the task feature, there are different options available. Looking at the task backlog, there are no tasks that have been created to this point. By going to the Add Tasks tab, a new task can be created. First, by filling out all the values in the form, giving the task a name, giving the task a description, assigning a value to the task, assigning a priority to the task, and finally setting a start date and an end date of when that task should be due. Submitting the task form once again sends an API request, sends a request back to the API, and then to the database, creating a new row within the task table. By navigating back to the task backlog and refreshing the page overall, we can now see that this task has been created. From the task backlog, a task can now be assigned to a user. By clicking on the specific task, there is a drop-down option that shows all of the users within the group that the user is currently signed into. By opening the drop-down, you will see there are two different users that this task could be assigned to. I will assign this task to myself, submit the task request, and once again, refresh the page. By refreshing the page, the client makes another API request to the database where tasks are once again read. Looking at the complete tasks tab, you'll now see that there is a task with a status of new represented in this table. You'll also see that there is no complete date and that the isComplete value, Boolean value, is set to false. If hypothetically I've completed this task, I can then expand the additional information by clicking on the row and clicking on the complete task. Completing this task automatically updates the status as closed, applies a completed date time, and sets the isComplete value to true. Looking at by expanding the left navigation bar, There is also a purchase option that works very similar to tasks. There's a purchase backlog for viewing all of the purchase types, a way to add different purchases, and a tab to complete purchases that become assigned. The difference between a task and a purchase is that a task will add a value to the user's bank value, where a purchase will subtract that value. Finally, going to the bank option of the application, the user is able to see their current value, their current balance as it stands within the database. I can see that the bank ID that I have associated in the database is ID number 3. I currently have a bank value of 2, which is related to the task that I have most recently completed, and I can see the date time that this bank value was last updated on. If I'm ever curious, I can look at the tasks, at the recent tasks, and see what I have completed for tasks. The same is true for a purchase, once one has been completed. While this was a very quick overview of the application, there have been next steps to identify work that should be done next. That work could make the application more appealing to users. Some of this work includes adding progress bars and additional keys to the user interface to show when HTTP requests to the API have been completed or currently in progress. Additionally, adding user notifications based on the HTTP responses would be helpful for the user to understand, has their submission been accepted by the database, by the API in the database, or has their submission been rejected by the API in the database? Additionally, the notifications to the user could help identify if a missing value is the cause for the failure, or if it's a connection between the application itself. Finally, as it may have been seen throughout the overview of the application, some of the CRUD operations are missing on pages. For example, looking at the task tab, there is a tab to modify tasks. The idea behind this was that a task name may not have been recorded as intended, or a task description may not have been descriptive enough to let the assigned user figure out what they needed to do. The API currently supports some of these changes, such as updating task name, updating task description, value, status, and priority. However, the user interface does not support those features yet. Additionally, next steps for this application could be publishing all of the components to either a dedicated server or a cloud environment. As the application is currently, all of the components, including the client, the API, and the database, need to be running simultaneously. They also need to be running, they can also only run on the local host network. Moving forward to a published application in the cloud, a Microsoft Azure environment or Google Cloud environment could support the client application as an app service and host the database connections. Lessons learned. From this project, many things were learned. Perhaps the biggest key is to start small and expand the project as components become completed. This is evident in some of the CRUD operations that have been developed in only portions of the application. Additionally, many construction techniques have been learned and built upon. Version and control using GitHub, and design specification using both Microsoft Visio, Lucidchart, and the Swagger library for open API specification. Overall, this project has helped expand on many of the technologies put together within this technology stack to create a complete and useful application that, with some more work, can be one day utilized in a real world scenario. Thank you for your time for listening to this presentation.